Well, I wasn't sure what the backgrounds of the group of people were that I was going to be speaking to. So what I've decided to do today is talk for about 10 to 15 minutes about some of the projects in the lab in general that we do. So a little bit about what the Create Lab is, how we engage with people, a few of our projects, and then I'm going to launch into one particularly which is about school science and using sensors in the curriculum. So I'm really happy for people to stop me as I'm talking, ask questions if you want to, very welcome to. Very happy for it to be interactive, so I can answer questions at any stage. Or I tend to talk quite quickly. If I lose anyone, just say, and I'll go back. So we're based in Bath. For anyone who hasn't been to Bath, it's a beautiful place and really well worth visiting. We're a team called the Create Lab. My background's in psychology. And Chris Bevan, who's sitting over there, is also from the team. He's also a psychologist, but sat in computer science as well. We are an interdisciplinary team. There's about 12 of us. We sit in psychology, but we sit sort of at the intersection of psychology, computer science, and education. It shouldn't be moving on, so I might have to slow that down. This just gives you a bit of a flavour of the people in the lab, but they've got backgrounds from as diverse as maths, we've got designers, we've got people who are computer science, education and psychology as the core units. And you'll see in the middle is our Now robot, so this is one of our newer projects. What I want to talk to you a little bit about is the way that we work. So as I said, we're psychologists, we're trained in, many of us are trained in quantitative methods. But actually we use mixed method approaches, so we're methodologically we'll be using quantitative and qualitative methods in our research. We also do a lot of co-design and participatory design. So we're not well, we do some lab studies, but we don't tend to be psychologists who sit in the lab and just bring participants in and do quantitative studies. We do go out there and interact with people that we want to build technologies for, and you'll see later on in my presentation, particularly when I talk about the schools, but actually all of our projects, that we engage with whichever user group we're going to be working with. So if it's schools, we're in the schools, engaging with the teachers and children, and that's whether you're a psychologist, a computer scientist, a designer, we all go in and engage because these are the people who are going to use our technologies, so we need to understand how they're going to use them. So it's part of our philosophy as a lab that we do co-design, participatory design, people call it different things. There's, as probably some of you all know, I don't know everybody's background, but you know, there's pros and cons to this. People say, well, do you want to work with people as participants, as co-designers completely? Do you bring your participants, whether they're museum curators, whether they're members of the public, whether they're teachers, actually into your design process so they become like researchers and work with you through, say, a 3-year project? Or do you want to work with them as informants who tell you more about their environment, but they're not actually part of your design team? And there's a bit of a continuum there, and I'd say we're in the informants part of the continuum as we work. So, as I hope you'll see throughout the presentation, we work intensively with all types of different user groups. And sometimes these are on short-term basis and sometimes they're long-term basis, and we call these cohorts of participants who run through 2 or 3 years of our projects. So we use a process of iterative design. Computer scientists sometimes don't like this because they say it slows down the development of the technology that we're developing. And that's true, actually, it often does. But the more we learn about context and users, normally the more the technology is used following implementation. So that's our philosophy. We engage really broadly. So you'll see some, I'm going to talk about some of our studies in a bit. You'll see some of them are lab-based, some of them are in the wild, which I mean outside, whether it's in the school, whether it's in a museum, wherever it is. We have a lot of industry collaborations, so we work with Microsoft, we work with the BBC, we work with BT. We also work with small companies, SMEs, and the project I'm going to tell you about is working with a small sensor company based in Bath. So we work with a range of industrial partners who fund, that's moving on, who fund some of our, oh, I'm whizzing you on, sorry, who fund some of our research projects, and also who we have people working in their organisations. So we have somebody at the BBC 75% of their time, for instance, somebody working in the sensor company 75% of their time. So we have a lot of working very closely with industrial partners. I don't know whether that keeps moving on. Sorry, I'm going to skip back one. And then I've probably pinched a slide from someone else and it's had an automatic timer on it. We also do a lot of public exhibitions, and we do things like Going to Bet, which is the British Education Trade Show. We do Bath Taps into Science, so we're very much about public engagement of our work as well. And I shall move on here. So I hope what you'll see throughout the projects that I tell you about today is that we have this sort of quite wide approach. So we look at mixed methodologies, we look at a co-design process, and that we go beyond just the studies to try and engage with the public in all sorts of different ways. There's 4 projects that I've selected. We've got a whole number of projects going on in the lab, but these are sort of 4 of our major themes at the moment. The first one's an EPSRC project called Super Identity. Second one's the Being There project that Hatice mentioned, and we're working on collaboratively with QMUL. And I'm just going to say a little bit about each of these projects, just a few minutes. The third one's the AHRC React Hub, which is quite an interesting one because it's about fast design with creative industries and with academics, which is a funny thing to say in itself because actually academics work at a very different pace to creative industries. And finally, I'm going to go in much more detail into some of our work on mobile sensors in the classroom. Hopefully everybody's with me. Are you clear on what I'm going to do? Yeah. So I'm going to go through the first 3 projects, and it really is just going to be a brief tour of those projects. So the first project I'm going to talk about is a project that we've, an EPSRC project. It's called Super Identity. It's actually just in its, we've had an extension, so it's gone into its into its 4th year now. And what we're doing is we're looking at identity online. And we're working with a big interdisciplinary team, and you can see who they all are there. But we're basically looking at how you can link different concepts of identity. So people have been looking at things like fingerprints, the way you walk, your gait, and a lot of aspects like that about your physical characteristics in terms of your identifying you. And we've started looking at your online identity and seeing if you can match that and your psychological characteristics. So, for example, can we tell things about you from your blog writing? Can we start linking that to some of your physical characteristics? Chris has been doing some work on swipe gestures on mobile phones. From a swipe gesture, he can tell something about your gender, about your age. So you start thinking about, can you link identity through different factors, so through biometrics, through physical characteristics, through technology use in all different ways, from hardware to online. And what we're doing is building a model. So the group at Oxford are developing a model where you can start linking these characteristics and looking at how confident you can be about somebody's identity from a number of these. So you might find something out about them physically, you might have something about them online, and if you link these, can you start telling more about this person? So it's a really quite exciting project. It's brought us into some quite different aspects of identity and trust, and thinking about the social acceptability of this sort of work. So from our perspective, Oxford are building the model. There's people who are interested in biometrics. We're very interested in identity online, but we're also interested in the social acceptability of this type of work. And we've worked with a cohort of under 18s over 2 years, developing the methods with them and getting lots of feedback on the type of identity measures that they would be happy. But it's quite interesting actually, because they're really much less worried about privacy than you would expect they would be. And there's lots of research that shows that they're the main users of online facilities, but actually they're the people who read the least about their protection. But actually many of them are very, very savvy about what they're giving away, this sort of identity, and they feel that the risk of giving things away is worth it for the actual things they're obtaining from being on a social network. So we're doing some really interesting studies with them. We're also getting them to run alongside the project, so they're doing things like using the model and seeing if they can identify people from different features, and then start to see if they understand how it should be used and can give us feedback. On the other side of the project, so there's the children, on the other side we've got intelligence agencies who are also trialling our products. So we've got, they're using the model with people who work in the banking system, people at GCHQ, and a whole number of other organisations to see if it's useful for them in terms of getting more intelligence about people's identities. So there's all sorts of interesting ethical, social acceptability issues around this project, but also really exciting project with lots of sort of different aspects to it. And Chris has been sort of running alongside it, doing a lot of the swipe work, and that's been really interesting in terms of a theme of experimentation that's quite novel, looking at how we can combine our expertise in mobile devices with the identity work that's going on. So that just gives you a flavour in case anybody's interested in that type of project. And also, I'll have a link to the websites on my slides, so if anybody wants to look at any of those. The second project I'm going to talk about is Being There. It's humans and robots in public spaces, and you might have heard, I don't know if Hatice has talked to you, you haven't talked about it. Okay, so the second project is a 3-year multidisciplinary project. It's with QMUL, and we're working with Hatice and Oya on this project, and Chris, who's here as well, and myself for the Bath team, but there's also a team from Bristol Robotics Lab and the others that Hatice mentioned. We're looking at how you can move towards a situation where you're in public space with robots and you can effectively interact. So thinking of scenarios if for some reason that you needed to interact in a public space, but you couldn't physically be there. So we're thinking about telepresence, and we're looking at the social cues around that. So what would make a robot more trusted in particular public spaces? We're looking at cooperation, emotion, obviously, working with Hatice and Oya. And we're also doing a lot of work around, say, location trackings, and we're trying to tie all this together to build what we're calling a living lab. So we're having experiments, we're all doing studies in our own labs, but then we're doing work that's in the wild, which will be in public spaces. Most of that's going to happen in Bristol, because we've got permission from there, excuse me, from the Bristol City Council to do this work. And we're also working with the Watershed in Bristol. I don't know whether that will mean anything to anyone. Does anybody know the Watershed? Oh, it's a creative arts group, and they also have something called the Pervasive Media Studio, where they have about 50 researchers working across arts, humanities and digital media. And they're working with us throughout the project to make us be a little bit more creative, because we're all set in our disciplines and we're all thinking either from a psychologist's viewpoint or an engineer's viewpoint, and they're trying to pull us out of it a bit by thinking about what might be more creative about doing things in public space. So you know, how it would work, getting us away from thinking we've got to do this in this particular way to thinking here's a puppeteer and this is how they would do it, and sort of trying to pull us out of the way that we normally work, which sounds a bit odd, but it's actually really, really effective in terms of design. So this project's ongoing. We're about just over a year in now. I'm going to show you some of the, I didn't know if you'd know this, so I've got a slide in, but I was going to whiz over it if you all knew about this project. So we're working with a number of robots. I mean, primarily we're working with the Now. Hatice has got a Now here. We've got one in Bath, and the Bristol Robotics Lab have got a whole number of robots. So we're primarily working with this. As you can see, it's a particular type of humanoid robot. It's actually very tiny. It's about so big. And there's particular characteristics about it. And if we're looking at trust, for example, it looks very much like a child. It's got quite a, it hasn't got a particularly adult humanoid look around it. So we're trialling other robots as well. So the PeopleBot, which is the traditional one, which is just like really a monitor on a stick. Poppy, which the Bristol Robotics Lab are developing at the moment and developing fingers and joints for it. And RoboThespian, which is one they've used in the past. We haven't experimented with that yet. And we're carrying out all sorts of studies looking at, from Bath's end, we're looking at trust and cooperation. So Chris has just done a study looking at handshaking and whether you get the same sort of interaction if you do that via a robot as if you do it with a human. So are you likely to still negotiate in the same way? And the other thing we're doing is a load of public events, which is quite challenging actually. It's quite challenging for us all to get together and create something that can run as an effective public event, but also brings in all our research interests. So that's something we're working on at the moment. And we're getting some creative partners from the Watershed to come and work with us. So, yeah, actually, will they come here? They're not coming here, are they?
In April, I think
Oh, they'll come here as well. So some will come here. So we'll have people working across the partners, trying to get us thinking about different ways of our studies. They might think differently about the handshake study, for example. We do it in a very experimental way and have a control group and a participant group. They might do it in a completely different way in public space with people not trying to control it. They might record what people do in a very different way to us. So we're sort of trying to get a bit out of our comfort zone in order to understand how to work very effectively in public space. And the creative partners are coming to us, so we're having residencies. We've got one coming to Bath in April to work with us for a week, and you'll have somebody coming here to QMUL. There's all sorts of things going on this project that I can't go into in depth, but we're also obviously looking at gestures and all sorts of things around how the people and robots interact. We've done quite a lot of public engagement events. Chris and I have done some where you have to go and talk in a pub, and he's talking remotely through the robot, and I'm doing the talk with the robot, and it's actually really engaging, but also quite a difficult technical setup, but it makes you think how restrictive the robot is. You know, we're all excited about working with them, but there's only so much expression and so that you can get from the robot. So that, I didn't know, I thought you might know lots about that, so I've only got a little bit on that, but that's quite an exciting project that's going on here as well, so if you want to know more about that, there's a link to that as well. I am racing through this, so if I lose anybody, do just wave. Everyone's very quiet. Everybody with me? Yeah, thank you. Yeah, okay. So the third project that I'm going to give you a brief overview of is a project called React, and it's a different type of project, but it's actually a really exciting one because it's almost a meta project. So React is a project funded by the AHRC. So these two projects are both EPSRC and tends to be where we get the majority of our funding in human-computer interaction. Interestingly, this is a project about engaging creative industry again, but with as many arts and humanities researchers as possible. So often people who are very much in their own discipline and haven't thought about working with creative industries. So it could be a historian who normally works pretty much on their own, learning about particular buildings. It could be a writer who's from an English department. So the idea is that you try and see if you can develop projects with creative industries using digital technology, and hopefully it'll become a bit clearer in a minute. And we were funded, we got a large, AHRC did their largest funding tranche, because they normally fund smaller projects, and they funded 4 £5 million hubs. And we've got the Southwest hub, so it's Bristol, Bath, Exeter, UWE, and Cardiff. And basically what we do is we get this money to almost act like the research councils. So we put out calls, and we say we've got a call, and these are the cool themes. So we've had heritage, books and print, future docs, objects, which is like Internet of Things, and play. And basically we put out a call, and people come forward, creatives and academics, and apply for projects. And then they run through something called a sandbox, which is a really fast 3-month to 5-month development period where they have to come up with a prototype product. So they go through an R&D process, and they get to all sorts of different points, as you can imagine, but they normally have some sort of prototype running, and they have to have done some study of that. And let me give you a few examples of plays running at the moment. There's 6 projects running. They are looking at everything from a game like Jenga that's being developed with engineering, and a lot of the work's using vision in order to see if you can do the most risky game. So if you can move the pieces in the most risky way, you get less points, or more points if it's more risky. They're developing that with a games designer, there's an engineer, there's a product designer, and they're all working. They've never worked together before, and they've got this concept, and they're developing it. They're using 3D printing to print the blocks, and they're working really closely with a group of children they've never worked with before that's run through the watershed, and they have to design and develop with this child user group. Another project, for example, is somebody from education. Her background's in maths and looking particularly at people with Down syndrome. She's working with a film director and an app designer in London. They're developing a online environment for children to play games, to develop their maths skills, and then they're turning that into an app. So it's moving the research and the creative. So the creative gets the research from the academic and works with the academic to push the research into their product. And from the other side, the academic is getting a whole different experience of what their research, where their research could go. So hopefully giving some different ways impact to their research. So these projects are, it's quite an exciting thing to be involved in. So we sort of sit at the bit where all the proposals come into us and we develop themes and fund 6 to 8 projects each time. So far we've connected with 385 companies and 287 academics. We've invested 1.9 million, so we've got this pot of money. We've invested 1.9 million in 53 projects. So it's quite a lot, and these are, most of them are Southwest, because it's part of the Southwest Hub, but people can come in from other places linked to a Southwest partner. So as you can imagine, this is quite, they're 50k normally a project, and these projects develop over 6 months, and then the majority of them continue applying for research funds or applying for venture capital or whatever, it depends where they're going. 14 products have secured 381k of further investment, and that's from the first 2 sandboxes, because some of them haven't finished yet, and generated over 1 million in research bids from this project as well. So it's quite an exciting project in terms of its scale, and in terms of how creatives are working with academics, but also in the themes that are being covered as well. So it's a broad set of themes, but it's all around the implementation of digital technologies. Objects, for example, was very much, it's called Objects because you're looking towards an audience who are arts and humanities based, but actually it's very much, if you know, I'm sure most of you will, the term Internet of Things, they're Internet of Things projects, they're connected objects. That's what people are working on. So actually it's quite nice in terms of how you can see an overlap between the engineering side and the arts and humanities research, and lots of them are collaborating across departments. So we've got electrical and mechanical engineers collaborating with product designers and artists and filmmakers. So it's quite nice to see that interdisciplinary approach. Right, so that's my 3rd project, and I'm now going to delve into the 4th one. And just so you're all clear, so I've covered 3 projects that we carry out in the lab. So the Create Lab runs all of these 3 projects, and this is the 4th one. And this is the one I'm going to talk about for the next, not so long, 15 minutes or something. And this is a theme of work that's carried on for probably about 15 years now, actually. We've been developing technologies for schools for a very long time. We've started off by using virtual environments when they were particularly popular, end of the 1990s. And worked for 10 years developing virtual environments for children and for children with disabilities. We then moved into using more tangible interfaces for developing toys and physical displays for interaction in the classroom, particularly around literacy. And then about just over 10 years ago, we started having a real focus on science. And that was partly because of some of the projects that we got, which I'll talk about in a moment. Partly because there was this push by the government to say that actually there's a lot of technologies that aren't being used in schools. A lot of schools are required to buy these technologies, sensors for example, but they're put away in the cupboard because teachers don't find it easy to use them. And there's a problem on the other side of not enough children going into science. So in the UK, the number of people going into science drastically dropped. And one of the problems that was identified was this move from primary to secondary school. So in the UK, when you move from, you go from 10, 11, you move to a secondary school, the curriculum changes absolutely drastically. So you go from quite a creative environment often in your primary school to a very 40-minute slots, quite aimed towards assessment type of environment, a very different, not as easy to put creativity in and not as easy to implement technology in some areas as well. So that's a very broad, overview, but that's the sort of context that we're working in. Now, from our lab perspective, hopefully, as you gathered already from how I talk about the projects, but we're very much about working with people to develop technology. So we work with children and teachers. And because we've been doing lots of work on mobiles and we started working with a sensor company, we started to think, well, how can we apply our hands-on approach? So our approach is very much about people going out and collecting their own data. And how can we do that in a participatory design method that also enables teachers and children to do this on their own, so it's not just about us doing it when we're with them. So I've said some of this already. There's a lack of interest in science amongst school children. This is a problem for policymakers. I'm actually spending some time at the Department for Education at the moment in Westminster on their STEM policy. So a lot of the research that I'm talking to you about briefly today is I'm trying to feed it into policy. So I know some of their STEM team, particularly the people in technology and maths, and they're looking at how to improve technology in schools and how to make it more applicable. And so some of our research is feeding in that way. There's an interesting debate that I won't go into in much detail, but you're probably aware of, but I think it's interesting when you think about this area is, as researchers, should we be, when we're talking to children and teachers about hands-on science, you know, getting interactive and thinking about whether that improves learning, are we thinking about scientists, because the government is saying there's not enough scientists, people going into science, which is important, obviously, but also having a scientific a public that is scientifically literate is another way of thinking about it. It doesn't have to be somebody who's going into physics, but it's actually people being able to engage in debates around the environment, for example, that they're in, or local government, or just get engaged in collecting data and understanding data. And we've written about this, and others have written about how important it is to have hands-on experiences when you're collecting this data, rather than just, say, the teacher producing a graph and you analysing that graph. We've done lots of projects, as I said, about hands-on learning, and a lot of our previous projects, so I won't go into all those today, but we've done projects out in the wood collecting data with children and teachers. We've done some projects around history and developing timelines with pieces of technology. They show that a good understanding, a good collaboration and a good contextual understanding of the environment really helps learning. So I'm just going to quite quickly race through a few projects that I hope will give you a flavour of this work. And some of them are really early ones, so this is quite a long time ago, and you'll see by the technology it is as well. So we work with children as pollution scientists. Basically, it's two smalls. This was a small project funded by JISC, and we looked at a school in Nottingham and a school in Brighton, and we gave them CO sensors, and you'll just see how old the technology is here, but this was 10 years ago in schools, and they had, had to have GPS separately. They had to have their sensor was a big block. It was actually a UCL sensor. Ben Croxford at UCL had developed this sensor, and we were working with him to develop the sensors further. And they had a PDA at that time as well, so it wasn't even an iPad or anything. And basically, what we were doing as a project, looking at seeing if children could do hands-on learning about carbon monoxide in their environment. And we were seeing how they would work with the technologies and developing some very simplistic software tools for them to work with. So just very briefly, children at each school were asked how they wanted to design their sensor. At the top left, yeah, it'll be left for you, is, right for you, sorry, is the sensor from the older children, 13 to 14, and they wanted to put it on what we called a T-tray, because what they wanted to do was monitor traffic at particular times. So they wanted to put it down, leave it there safely. The children in the younger school produced this. You can just about see it on there. It was a sensor on a stick, and they actually, quite cleverly, I thought, coloured it like a Rubik's Cube. And the reason they did that is so that they could see which way the wind was blowing, because they have a ribbon on it, and also because they could see which way the hole was on the sensor, because then when they viewed back on the video, they could tell what was going on. So what they actually did was they went around, they explored their environment, over a number of sessions, we worked with them to develop their understanding of the environment. So they explored the environment, captured data around carbon monoxide, and then it was graphed in real time. And as they graphed it, One person collected notes, one person was using the sensor, and the other person was recording what was going on a video camera. And then what we did was we synced the video data with the graph. So very simplistic, but they could then easily go back to what they were doing. So as they moved through the graph, they saw what they were doing in the environment. And quickly, children start to understand that the sort of things they film and the context they've got affects their data. So for example, there was a peak here, and when they looked at it, there's nothing happening in the video. So they don't know why there's a peak in that data if they're looking at that graph afterwards. But actually, if they look at a few minutes, well, it's like 2 minutes before, there's a whole load of lorries going past. But there's a delay in that carbon monoxide reading, as there would be. And they start to realise that actually factors like that start to affect their graphs, and the context of what they're doing is actually really important in terms of the data that they're collecting. So as they start to understand the context, they start to record things in a different way, and they start to think about their data in a very different way than if they just received a graph in the classroom, for instance. So there were a number of outcomes of this. So we did qualitative analysis, and we video recorded all of their sessions. We found that individuals could reflect on method, which I've just been talking about, as part of data collection. It provided an aid memoir to groups in terms of collaborative learning and talking about their results, so they could collaborate around the video as well as the graphs. And also it enabled them to share across different places. So the people in Sussex shared their data with the people in Nottingham, and also Ben Croxford at UCL. So he was the expert who had data from all around London. He'd been cycling around with the sensor in his bike. And he collected a lot of data in the same way and shared it over the same interface. So he started thinking about all the factors, and they engaged with him as an expert in that. And what becomes really important is that the data, and many of you all know this, but actually in a school context you often don't get this, that not just having the graph or the data is the important bit, understanding the context, the way that you collect, the cycle of hypothesizing through to analysing your data is really important, and that the context really adds a lot to what children start understanding about the data collection and the data analysis. So working from that, we got a large EPSRC project called Participate. We worked with a whole number of partners, including Nottingham and many others, looking at scaling this interaction up, so looking at really large-scale monitoring of sensor monitoring. And I'm just going to really give you a brief bit of that because it's a 3-year project with lots of aspects to it. But very briefly, we did a whole number of studies looking at children collecting data to and from school. They took the sensors off with them, they collected the data. Now we've got sort of GPS involved, we've got they've got video cameras with them that they do it without us there. The teachers, we train the teachers to be able to use the sensors and to upload these sort of images. We're now working with a small sensor company who we've worked with for the last 10 years in Bath, and using their sensors as well as using mobile phones to collect data as well. And the readings that they get are displayed in graphs like this in Google Maps and Google Earth. So we're sort of moving the technology on, again this is a few years ago, moving the technology on and seeing how this affects children's understanding of their data. So that just shows another of the images. And again, we start to find, I won't go into detail, but we start finding more information about the context where children collect their data is important to understanding and learning, and also motivation, which is interesting. So we measure learning and motivation. We find that children can instantly work out where things are higher and lower on routes. They start to identify with their work, and interestingly, how you set that up is important. So if you give them everything integrated, the assumption was that if you gave them everything integrated, you showed them a nice graph, they could go along like on the other one, find their bit of data, and they could put their images straight in there, that would be the best way of doing it. But actually, when you gave them quite poor quality things afterwards, if they had got the context behind it and they had to work it out for themselves, actually sometimes that was a better learning experience because it initiated more discussion among the pupils. So it's quite interesting in terms of how you think about interfaces for learning, whether you make it all automated, so it's nice and easy and feels more effective, but actually if you make it too automated, you might dumb down the learning that's taking place. Just moving on. So we moved from this, Participate was a massive study, and there's lots I could tell you about that, but I'm going to move on a bit from that, because in Participate, we did a lot of monitoring of data collection, of thinking very carefully about how we use the sensors, of developing the sensors. It was we did a lot of qualitative work and found some really interesting things around context, as I've told you. It was quite hard for us, and as psychologists, we wanted to capture some quantitative data, and actually, if you want to feed into policy, or you want to really, really persuade someone that technology works in the curriculum, they do want quantitative as well as qualitative data. So a nice case study to show something, but people want to know, did children learn more with that technology than without it? Very, very hard to show, but we thought we need to start working to see if we can capture some of that as well. So we've done a number of studies, and I've just got two here to briefly show you. And the first one is looking at context. And we had a controlled study where children explored particular environments with sensor technologies. Some of them didn't experience the outside environment, and some of them did. And they were given different degrees of either they worked on their own or they worked with a peer who had been outside. And then we set it up so that they had to produce graphs and analyse these graphs. And then we analysed their learning and their motivation. And what we found was that the intervention revealed much more of an effect on motivation than learning. Now, it's not particularly surprising because this is a one-off study. They did this once. So you wouldn't expect a massive effect on learning. But students who collected their own data were much more comfortable working with their own data than the data collected by a researcher. Again, not that surprisingly, but often what you would do in a school. You wouldn't necessarily analyse your own data. They felt they could explain their data better, and we started to think, could we implement this in a school environment and actually get a teacher to work with us, rather than doing a lab-based study, to actually work with us and get us to, so we could help them design their lessons. And so Susie, who's one of the PhD students in the lab, was funded to do some studies looking at whether she could develop sensors that worked with the curriculum. So she worked really closely with a science teacher over a whole semester. She developed, there were 6 modules. 2 of the modules she developed with sensor technology with the teacher. So the teacher did the lesson plan as they normally do it, but they integrated the sensor technologies that they don't normally use. So these educational sensors. The second module had had a camera as well. Second module had a camera as well, so you've got a control for some sort of technology in it. And a third one that didn't have anything, just ran as it normally ran. It was the same teacher running all the modules, and the researcher sort of was in the background as almost like a teaching assistant through all the sessions so that she could record what was happening. And then at the end, the teacher assessed each module based on their normal teaching criteria. It's a Longman resource, and they mark each student. And very interestingly, we found that the inclusion of the data loggers and sensors, there was an increase in assessment scores. So just in a set of science lessons, it was about 34 lessons in all, we found an increase when they were using our technology. It was really interesting. Of course, we don't know all the ins and outs. We've got some qualitative analysis, but we don't know all the ins and outs of why. But we do know it's the same teacher running in it. It starts to give some evidence of where, if you use these types of technologies, they can enhance learning. I'm conscious of time, so I'm going to race through the last bit and just tell you very briefly. So work we're doing now is much more around what you might call an internet, and you could debate what Internet of Things means, but an Internet of Things experience. So one of our team is based 75% in the sensor company that develops the educational sensors, and he works 25% of the time in our lab. And what he's doing is he's doing a project where he's very integrated with schools across the country. So he's Ridlington School and Haysfield Girls' School, the main ones he's worked in, but he works in all these others as well. And he's developing all sorts of sensors. A lot of them are static sensors that are talking to lots of static sensors, say weather stations he's got running, that are talking to a central server, and then he designs the visualization so in real time you can look at the weather at each of these places. And then he's developing curriculum material and working with the teachers to evaluate how the students are using this, what they could do as lesson plans. And this has been really effective, and they found they're actually, one of the county councils is starting to bring this in as part of their curriculum. So he's doing some evaluation. He's just finishing his NGD, so he's in his 4th year of his NGD, and he's doing some evaluation. He's doing it through all sorts of interesting means. He's done normal sorts of assessment and teacher interviews, but he's also got comic books where they have to show how they think the technology worked, and all sorts of measures of learning and motivation. So that's going to be quite interesting for us to see soon. So finally on that bit, I've got 2 slides here, and to be honest, for us it's really exciting working with the user groups and actually seeing the work that we're doing put into practice. It's one of the things that it's very applied, the type of research we do. We have an emphasis on recruiting cohorts of partners, so we work really closely with these schools, but as you saw before, hopefully, we work closely with lots of other groups of people as well. We've, in a project which I haven't had time to mention today, Cityware project, we work with a group of participants across 3 years designing mobile technologies for the city, for Bath. We've done work, as I've mentioned earlier, looking at identity with a cohort of teenagers, looking at social media. So for us, that's a really key theme in order to get things actually do interesting research in terms of quantitative and qualitative research, but also start seeing if we can get some of our research into practice in all sorts of different ways. We're interested in integrating into the curriculum, informing policy, as I mentioned. Our co-design methods are really important. We want to do work in the wild. So when we're working in the wild in schools, that means working in schools, working in learning centres. When we're doing work on the robotics project, it might be in public settings. We're very much about thinking how we can get our research used in public spaces. And in terms of the education, it's quite interesting. So you can think about children making their own technologies. You know, there's Arduino, Raspberry Pi. There's all sorts of ways that children will be getting more involved in how you use technology in the classroom, because there's a new, as you probably all know, there's a new computing curriculum where children started programming from primary school age, came in this year. So that's sort of going to be part of our UK policy. So it's quite interesting in terms of how that might change things, excuse me, in the future in terms of some of the technologies that we're using. There's a widening gap between schools and technologies use. So children are often, you know, when children are learning Scratch at 6, and there's a number of teachers who've never used it, there's this widening gap of whether the teacher's going to be the facilitator, the teacher, how are they going to manage that? And that's quite interesting for us in terms of the research that we do. So do schools become technology curators? How do they work with children? How do they make sure they get on their hands-on experience that they need and want, and we show is effective to learning and motivation? So there's some quite interesting questions there for us, and many more as well. I'm going to finish there because I've whizzed through 50 minutes, and I'm sure you're also like, oh gosh, that's a lot of projects. But hopefully I've given you a flavour of the sort of things that we do in the Create Lab at Bath.
Thank you.